Hello, welcome to the channel. In this video I'm going to be making a 6-meter RC plane from 1-inch XPS foam board. I started out with a CAD design. I chose a flying wing because they're typically the most efficient and have the least wing loading, which is good when you're using materials that aren't particularly strong, such as XPS insulation foam. My plan was to make the plane split into 3 parts for ease of transportation. I managed to fit all the parts of the wing onto one sheet of 4x8 1-inch XPS insulation foam board. I then proceeded to draw out each section of the wing on the foam board, and then cut it out with a sharp razor blade. I then marked some lines to cut along the foam board to create a nice airfoil shape. I also used some sandpaper to smooth out the wing. I then created some nacelle segments to act as the wing connection point and used some spray insulation foam to connect those onto the wings. I then cut out some slots in the wing to install some Ethernet cables to control the ESCs and servos. I used spray foam to fill in the gaps. After the main construction of the wing was done, I moved on to printing some servo mounts, motor mounts, and an electronics bay to hold all the electronics. I carved out areas in the wing to hold the servo mounts in the electronics bay. I then cut off the end of each of the nacelles to install the motor mounts. These motor mounts would have some slots in them to allow air to flow through and cool the motor, hopefully. I glued those on with Gorilla Glue. I then cut out the flaps on each of the wings. I installed the servos with some 3D printed control horns and used an old wire coat hanger as control arms. I used a thin silver covering film to protect the foam and add some strength. I used some small 6x3mm neodymium magnets to hold on the lid of the electronics bay. For the power pack, I used two 4215 650 kV brushless motors, along with some 40 amp 6S ESCs. Together, these two motors would provide around 5 kilograms of thrust with a 13-inch prop. I soldered the ESCs to the motors and soldered some X260 leads to the ESCs. This was quite tedious as the pads were quite small and close together, but I managed to get it done. After putting the plane together, I realized there was a problem with the design. The wing did not have enough sweep to be stable as a flying wing. Also, the front flaps were basically at the center of gravity, so they would be ineffective. So I decided to change the design of the plane to move the back wings back so that the front of the back wings would be at the back of the front wing, if that makes sense. I extended the nacelles with some extra foam that I had from another project. But this change in the design would cause a weak point at the connection between the two wings. So in order to fix that, I decided to make a biplane segment out of two long, thin wings that would go between the two outer wings to reinforce the whole structure. After extending the nacelles, I had to use a 50 centimeter X260 extender cable to move the batteries as far forward as possible. To connect the wings together, I used some small 3D printed clips that worked quite well. After putting the wing together, I noticed that the XPS foam wings were quite floppy. To fix this, I used some fishing line, which was not quite strong enough, intended to break. So instead, I used some aluminum craft wire, which was not the best idea as it tended to stretch and did not hold tension for very long. For landing gear, I printed some parts which would hold some skis that I made out of fiber reinforced plastic. After all this, it was finally time to test the plane, so I brought it to a frozen pond, as that was basically the only place big enough. After making sure all the flaps were working, I took off. Unfortunately, I do not have any video of that flight, as the phone that was supposed to be recording shut down due to the cold weather. But I flew about 50 meters, and when I landed, the landing gear broke because it was quite brittle. But I wasn't happy with just a 50-meter flight, as it only got 10 meters off the ground at most. So I brought the plane back and bought some thin wood at the local home improvement store. I used this to make some stronger landing gear. And and now it was time to test the plane again. But this time I made a crucial mistake. I forgot to balance the CG. This caused the plane to go up very fast, as it was quite tail heavy. It reached about 50 meters in 20 seconds. It then stalled and began to plummet to the ground. I pulled up on the flaps to try and save the plane, but this was a mistake and caused the plane to stall again at around 10 meters. This stall broke the plane in two as it was not strong enough to withstand that force. Here's that flight now.
I didn't balance it at all.
Uh-oh. Oh no. Oh no. Oh.
This crash broke the plane quite a bit, but I decided to repair it. I bought some more 1-inch XPS foam board and rebuilt the biplane segment. I also doubled up the front segment to hopefully create a better airfoil and create more strength. Time to fly it again. This time I thought I got the CG right, but apparently adding the extra thickness to the front wing caused it to create a lot more lift. So when taking off, the plane was still very tail heavy. The whole plane took off and flipped over and flew upside down right above my head for a couple seconds. It almost crashed into me, but flipped over again and crashed into the runway. Here's that crash now. Unfortunately, it was quite damaged and I was unable to fix the CG and take off again. This is the last flight for this video, but I plan to repair the plane in part 2. Thanks for watching, and don't forget to subscribe for part 2, where I will be repairing this plane and hopefully getting a successful flight in.